Have you ever just stopped and thought about how companies like Amazon or Netflix are constantly changing, but they never seem to go down? I mean, every single second, new code is being shipped completely invisibly. Well, today, we're going to pull back the curtain on the exact system big tech uses to deploy millions of updates a year without, breaking the internet. Let's get into it. And look, the stakes here could not be higher. Because here's the scary truth. Over half, a full 50% of all system crashes, all outages, all incidents are caused by one single thing: a developer pushing a new piece of code. That one action is the single biggest source of instability in the entire software world. It's kind of crazy. So the root of this whole problem, it really lies in this old assumption. For decades, the moment that code was pushed to a server, it was live. It was out there for users. Deploying and releasing were the exact same thing. And this meant every single update was a massive, high-stakes gamble. A single bug could bring the whole thing crashing down in an instant. So how did the best companies in the world solve this? Well, in this explainer, we're going to break it all down. We'll start with the foundation, the automated pipeline. Then we'll get into this really crucial difference between deploying and releasing. After that, we'll look at some advanced strategies for safe rollouts. And finally, we'll peek into the future with the arrival of GenOps and what it really means to build autonomous systems. Okay, so the very first step to shipping code safely, it's simple. Get humans out of the way as much as possible. See, manual processes are slow, they're inconsistent, and they are just filled with chances for error. The solution? A fully automated pipeline. And this is where CI/CD comes in. It stands for continuous integration and continuous deployment. And honestly, it's the absolute bedrock of any modern software system. The core idea is actually pretty simple. Automate every single step that happens between a developer writing code and that code going live. Now, what's really cool about this is how it builds this wall of safety checks. A developer commits their code, right? Immediately, a bunch of automated tests run to check for any basic mistakes. If it passes that, the system automatically builds the application. Then it gets deployed to a staging server, which is basically a mirror of the real thing, where another whole set of automated tests run, this time mimicking how real users behave. Only if that code passes every single one of these gates does it even get a chance to go to production. But look, automation by itself isn't quite enough. The real game changer, the idea that truly flipped the script, was understanding that getting code onto a server and making it visible to a user, well, those are two completely different things. So let me just ask you that directly. What is the difference between deploying code and releasing it? I know, it might sound like we're splitting hairs here, but I promise you this one distinction is the secret sauce behind how massive apps update without you ever even noticing. Let's just break it down really simply. Deploy just means the new code is sitting on the live production servers. It's there, but it's kind of dormant. It's invisible. Release, on the other hand, that's the act of flipping the switch and making that feature live for people to actually use. Decoupling these two things, that is everything. And the magic tool that makes this all possible is called a feature flag. I want you to think of it like a simple on-off switch that's wrapped around a new piece of code. This lets companies dark launch features, meaning they can deploy them to production, but in the off state. The code is totally live, but nobody sees it. Then, with just a click in a dashboard, they can release it to users instantly. And, just as important, they can turn it right back off if anything goes wrong. So once you separate your deployments from your releases, you suddenly unlock these incredibly powerful strategies to roll out new stuff with an almost perfect safety net. Let's take a look at how they work. So the first big strategy is called blue-green deployment. Just imagine you have two identical copies of your entire production environment. One is blue, and it's handling all the live user traffic. The other one is green, and it's just sitting there, idle. You deploy all your new code to the green environment, you run your final tests, and once you feel good about it, you just flip a switch at the network level. And just like that, all the traffic instantly starts going to green, which now becomes the new blue. The old blue is now idle, becoming the new green, totally ready for the next update. And the best part? If anything goes wrong, you just flip the switch back. The rollback is instantaneous because the old stable version was never even touched. Now, for an even more careful approach, there's the canary release. The name comes from that old saying, canary in the coal mine. So instead of switching all your traffic at once, you release the new feature to a tiny fraction of your users. We're talking maybe 1% or even less. The whole point here is to limit the blast radius. You push it out to that 1%, And then you watch your monitoring dashboards like a hawk. Is latency going up? Are error rates climbing? If anything looks even a little bit off, you can automatically kill the release. Only 1% of users were ever affected, and probably only for a few minutes. If all the numbers look healthy, you slowly dial it up, 5%, 20%, 50%, until you finally get to 100%. So all of these strategies, they've brought us this incredible level of stability. But we are now standing right on the edge of the next great leap. We're moving beyond human-controlled automation and into a world of AI-driven autonomy. Welcome to the era of GenOps. To really get how big of a deal this is, just look at this number. 1,300. That is the number of pull requests, of code changes, that are being produced every single week at a company like Stripe with absolutely zero human-written code. None. No, this isn't science fiction. This is happening right now. At Stripe, these tasks are being handled by autonomous AI agents they call minions. You give these agents a task, and they figure out how to solve it, they write the code, they write the tests for that code, and then they push it through the deployment pipeline all by themselves. Now, this isn't some free-for-all. It's all governed by a principle called bounded autonomy. Basically, the AI agent operates within a very strict set of safety rules. For every single change it wants to make, it calculates a risk score. Is this a tiny text change, or is it a critical update to the payment system? If the risk is low, it just proceeds automatically. If that risk score goes above a certain level, the system automatically stops and asks for a review from a human engineer. So what does all of this mean for the actual role of a software engineer? Well, it's changing, fundamentally. The job is shifting away from just writing code to architecting the intelligent systems that can write and ship the code for you. So how do you actually build these safety nets today? Well, you implement automated kill switches that can instantly roll back a deployment if a key metric looks wrong. You use something called trunk-based development, which just means everyone works on the same main code base, but you hide all the unfinished work behind those feature flags. You fully automate your user testing so that quality isn't a human bottleneck. And if you're using a system with lots of small, independent parts, you only deploy the specific one that actually changed. Which really brings us to our final question. As we step into this new GenOps era, we've got to ask ourselves, is the future of engineering about writing the next feature, or is it about designing the robust, intelligent, and autonomous systems that can safely ship thousands of features all on their own? The answer to that question is going to define the next